On number 7, we've already explained all the previous ones on the previous videos. We're going to start by doing step 1, finding the vertex. And we're going to use the formula. And of course, we're going to know how to use the formula with parentheses instead of the variables. And we're going to identify that the A value is what? The B value is what? -6. And the C value is what? -2. So we're not even using the C value. Let's plug in the B value of -6 and the A value of +3. So we really have a negative, which changed to a positive, because a negative times a negative is a positive. And we really have x equals 6 over 2 times 3, which is 6. So what does x equal? 1. There you go. X equals 1. So the vertex x value is 1. Once you know the x value of the vertex and you want the y value, Derek, what do? If you know the x and you want the y? That's right, you plug it in. So we're going to take that 1 and plug it in. So I'm going to rewrite this entire equation, but instead of these x's, I'm going to put parentheses. So as you can see, I rewrote the equation over here on the side instead of the x's with parentheses, and I'm going to plug in the number 1 for x. Check it out. Plugging in the number 1 for x. 1 right there, 1 right there. Start with parentheses. There are no parentheses or nothing to do inside of the parentheses. We move on to exponents. 1 squared is 1. So I really have 3 times the 1 that I got. And then, let me rewrite the rest. -6 times 1 and then -2. So then we move on to multiplication. 3 times 1 and 6 times 1. We will end up with 3 minus 6 minus 2. What is our answer for 3 minus 6 minus 2? That's -5. That's right. So our y value of our vertex is -5. So we put a -5 right there. The vertex is 1, -5. That's the most important point. Let's graph it. 1 on the x, -5 on the y. Whoops, it's over here on this side. I'm sorry. So that's our vertex. The very next thing to do is to draw your axis of symmetry right through that vertex. And if they asked you for the equation of this axis of symmetry, you would say x equals the x value of the vertex, x equals 1. That's the equation of that vertical line called the axis of symmetry. Now we need more points, okay? So we could go to an xy table, and I could plug in some numbers, maybe like 0, and then maybe a different number. I wouldn't want to plug in 1 because I already plugged in 1 on the vertex and got out a -5. I wouldn't even want to plug in a +2 because I'd get the same output as the first one. If you plug in a -1, that'll be great. But you know what, guys? If you know the shortcut of the pattern 1, 1, 2, 4, 3, 9, which only works with the a value of 1, this is a value of 3, we could modify that pattern. Let me show you what I'm talking about. See the pattern 1, 1, 2, 4, 3, 9. If you have a 3 as the a value, how does that change your outputs? It changes it by multiplying by 3. So instead of the input 1 giving you the output 1 on the pattern, it would be a 1, and instead of 1, it would be a 3. The next one, instead of 4, it's going to be the a value of 3 times that 4. So that would be a 12. So you could technically use the pattern. I like to say force the pattern. You could force the pattern as long as you modify your outputs on the pattern by whatever that a value is. You got that, Nathan? So all you have to do on this last one, 9 times 3, that's 27. That's not going to be on the xy plane. So anyway, let me use this pattern of 1, 3, 2, 12, 3, 27. Let me ask you this. Is this opening up or down? Up. Why is it opening up? Because the a value is positive. So my first pattern movement is from the vertex 1 over and 3 up. 1, 2, 3. Let's put a dot right there. And then the next one would be 2 over, not 2, 4, but 2, 12, because we modified the 4 by 3. So 2, 12. So you go 1, 2, and up 12. It's going to be off the graph, so I don't even draw it. All I need to do is mirror the coordinate over to the other side, and I'm pretty much done right there. Just please make it like curvish. Don't make it like a V. Some people just go like bam, bam, like a V. It's not really a V. It's still a U-shaped curve. It's just a little bit more narrow. Now, why is it a little bit more narrow? Because the A value of 3 made it more narrow. So let's say that you didn't want to modify the pattern. Let's say you actually wanted to use an XY table. All right, let's do that. If I plugged in a 0 everywhere would give me the C value of -2 as my output. So 0, -2, that's a coordinate. If I were to graph 0, -2, I get that blue dot anyway. Now, if I plugged in a -1, that's going to give me a value that's so high up it's off the graph, right? So I'm not even going to bother with that. So if you map it over, you're going to get the same exact parabola. So it's better to use your pattern. And in this case, we modified the pattern, okay? The 1, 1, 2, 4, 3, 9, that's only when the A value is 1. Whoops. So if you wanted to use the pattern 1, 1, 2, 4, 3, 9 on something that's not 1, like right here it's a 3, you have to modify your outputs on your pattern by whatever that A value is by multiplying it by 3. Let's do number 8 with the modified pattern. Let's, oh yeah, how about this? Let's do number 8 since it's fresh in our head, and then we'll go back and do the domain and range of both of them, okay? So number 8, let's first find the vertex, which is a coordinate. And we need to know the formula, x equals -b over 2 times a. We need to know that we're going to use it with parentheses, replacing the letters. And then we're going to identify the a value of -2, the b value of 4, and the c value of 3. We're not even using the c value right here. So let's plug in the b value of 4 right into the parentheses, the a value of -2 right into the parentheses. And we end up with -4 over -4. That's our x value. What is -4 divided by -4? That's right. X equals +1. Negative divided by a negative is a positive. So our vertex x value is +1. We need to find the y value now. How do we do that? Plug in the 1. And I'm going to plug it in with parentheses. And again, I am plugging in a 1 right in those parentheses. And I'm going to do the correct order of operations. Exponents first. 1 squared is 1. So I still have the -2 times that 1. And then I still have the +4 also times 1 and also the +3. So we're going to do multiplication after exponents. -2 times 1 is -2. 4 times 1 is +4. Bring down the +3. What is -2 plus 4 plus 3? 5. So my vertex y value is 5. So I have my most important point. Let's graph that most important point. 5 or 1 comma 5, 1 on the x, 5 on the y, you're right here, right on the edge of our 5 by 5 graph. Now, the very next thing to do after you draw your vertex is that vertical line called the what? Axis of symmetry, that's right. Now, again, if they asked you for the equation of this axis of symmetry, what do you say the equation is? X equals 1, that's right, that's the equation. The vertical line is x equals 1 of that axis of symmetry that crosses through that vertex. Now, we definitely need more points. I could go to an XY table. Or I could remember the pattern of 1, 1, 2, 4, 3, 9. But this a value is not 1. This a value is -2. Now, the negative, all that matters is that we know that it opens down. But the a value of 2 is going to modify these outputs. I need to modify the 1 by multiplying it by that a value of 2. So instead of 1, 1, what's it going to be? 1, 2. Instead of 2, 4, what's it going to be? 2, 8. Instead of 3, 9, what's it going to be? 3, 18. So this is the new pattern for when a equals 2. When a equals 2, you use this pattern. Now, I don't want you to memorize it, because I don't want you to get confused. I want you to memorize the original pattern for the a equals 1. What is the original pattern for a equals 1? 1, 1, 2, 4, 3, 9. And then if you ever have a different a value, you could modify the outputs of your original pattern so you could have your new pattern for your new a value. So from this vertex, what am I going to do to graph it according to the pattern? 1 over, 2 down. Put a dot there. Okay, so why down? Why not 1 over and 2 up, right? Remember, this a value is negative, and the negative tells you that the parabola opens down. Okay, so how about the next pad? We already did 1 over 2 down, 1 over 2 down. How about the next one, 2 over 8 down? So from this vertex, 2 over 1, 2, 8 down, 1, 2, 3, 4, 5, 6, 7, 8 right here. Put a dot right there. And now all we need to do is map those coordinates over to the other side. So put a dot right here, put a dot right there, and guess what? We're done. Put some arrows on it. We're done. Could we have used an XY table? Absolutely. Now, what's the easiest, if you wanted to use an XY table, what's the easiest number to plug in? So check it out. Plug in a 0. That's easy because this becomes 0, that becomes 0. 0 plus 0 is 0, plus 3 is 3. So the coordinate 0, 3, that's an actual coordinate. And if you did go from the origin to 0, 3, you get to that blue dot right there. Right? So that one was easy. But when you try a different value, like it would be pointless to do the number 1. Why is that? Because we already did the number 1 and plugged in 5. It would be pointless to do the number 2 even, because if you plug in the number 2, I already know that it's going to give me that output right there. So maybe you want to do either -2, -1 or +3. But as you can see, it takes a long time. I mean, you could do it if you wanted to. Let me plug in a 3. 3 squared is 9. -2 times 9 is -18. 4 times 3 is 12. -18 plus 12 is -5. -5 plus 8. I got confused. Too much math to do in my head. So show your work. Either way, you're going to get the same exact coordinates. So it's better to use the pattern, guys. Just make sure you modify your pattern. I did forget one thing. Let's go back and state the domain and range of all these guys, or at least of these two. So the domain of number 8, what do we say? X equals what? All real numbers. How about the range? What do we say? Y, is it above or below a certain value? It's below what value? The value of 5. Now notice I put below means less than, but I also put the or equal to because we know it actually does touch the y value of 5. And it's all below that y value of 5. So y is less than or equal to 5. That's the range. Let's go back up to number 7. We never stated the domain and range. So what do we say here? The domain is what? X equals what? All real numbers. Everybody should get that right. It's always the same, whether it opens up or down, whether it's wide or narrow. The domain is X equals all real numbers all the time. How about the range? The range is what? Y is greater than or equal to -5. That's absolutely right. Your y value of -5 is down here, which we know it touches, and it's all above that y value of -5. Or, I mean, it touches and it's above, so y is greater than or equal to -5. I hope this helps.